Right before I absentmindedly ran out of time, we were about to start an equation. Expression. Remember the difference between expression has no equal sign, and we were creating an expression that had no equal sign. Equations have equal signs. One of the things that we were going to do is we were going to solve an equation. Expression. Sorry, my brain is flip-flopping words. So I'm going to go ahead and I'm going to take a deep breath. And we're going to say the right word. So this expression is kind of what we were going to try before. And if we don't use our beautiful order of operations, we could find out how crazy our answer could have actually got. So we already did this problem in the previous video and found the correct answer, but let's do it in this format. So put on your bracket goggles. Do you see any brackets? No. So let's put on parentheses goggles. Do you see any parentheses? No. All right, let's put our multiplication and division goggles on. Do you see any multiplication or division? Yeah, 4 and 2/10 times 3. All right, is the multiplication step. So that's the first thing I'm going to do. And over to the side, instead of trying to do this mentally, we can just write the algorithm. I did it mentally in the last one. Let's make sure that Mr. Johnson was right. 3 times 2 is 6. 3 times 4 is 12. And then we have one decimal place. So we put a decimal place in our answer, in our product. So remember, count the number of decimal places. The number of decimal places are the amount of place values that come after decimal points in the problem, and make sure that you have the matching amount of decimal places in your product, which is your answer to the multiplication problem. All right, so we multiplied 4 and 2/10 times 3, and that gave us 12 and 6/10. So this is what's new. We did expressions before, but we never used decimals before because we wouldn't have been able to do this a couple weeks ago. But now we can. So we're going to copy down what we didn't use. We did not use the plus sign, and we did not use 2 and 1/10. So that leaves us with 2 and 1/10 plus 12 and 6/10. Once again, I can pull this to the side and do the math just so I don't mess it up by trying to do it mentally. 6 plus 1 is 7, 2 plus 2 is 4, 1 plus nothing is 1, and I drop that decimal point like it's hot. So our answer was 14 and 7/10. All right, so this is the correct answer. And I forgot to say we're on our addition subtraction step when we finally did add, but we only had one step left. But it is important to understand that we did all the multiplication and division before we ever started to add and subtract. All right, so what I'm going to do now is let's just pretend like the order of operations is something that we never learned. Let's see how different our answer would be. All right, so that would be the same exact problem. But if I didn't know the order of operations, I might add these two things first, right? So that would give me 6 and 3/10 times 3, all right? And so then if I do 6 and 3/10 times 3, I find out, whoa, that my answer is 18 and 9/10. Now that is a very different answer. All right, so the order of operations allows us to get the correct answer and allows everybody in the whole entire world to get the same answer. So the order of operations helps us to always get the same answer regardless of if we mixed up the order of this problem. Remember, if I use the order of operations, I have addition first in the problem, but I have to do the multiplication first because the order of operations states I have to do what's in grouping symbols first, and then multiplication and division, and then addition and subtraction. All right, so let me clear all my work and see what happens next. Oh no, why is this still looking all weird? Oh no, I've made many mistakes in the past 5 seconds with those clicking. Okay, so here we go. We're almost there. Now, so 2 and 1/10 liters is the amount of paint left in a jar. So if we go back and look at that original picture, that's what's left in a jar. Okay, that's starting to make sense. 3 more jars are purchased with 4 and 2/10 liters each. Okay, so they're giving this picture a lot more meaning. So this is like a jar that's been used. That's all that's left over. And so someone buys 3 brand new jars with the whole amount in each jar. They still didn't really tell us if that's ounces or liters.